So last week of October, this is it. We're about to jump right into November, which makes us think, oh my gosh, the semester is getting close to ending. Yes, so hopefully your grade is close to where you want it to end because we're over halfway. We're starting down the back side of the semester. Let's look at what is due this week. So this week, due by Halloween, Halloween Sunday. So this is due by Halloween. You don't want to do this on Halloween. No, get this done early. We have 3.07. That is the graphing polynomial functions lesson. And then we have the practice test, Module 3 review and practice test that is due this week. So we just have one lesson plus the practice test. And then next week is the discussion-based assessment and part 1 and part 2 of the test. Discussion-based assessment is a verbal, that's a fun word, a verbal part of the test. That's where you and I talk one-on-one. I ask you some questions about this unit. How would you do this? What's the process to do that? And you get a grade on just being able to talk and tell me the answers on how to do things. And then we have the normal part 1, part 2 of the test with that. So next week's just test week. This week is practice test and graphing polynomial functions. So let's take a look at that polynomial functions lesson then. The first thing it has on page 1 is a place you can print graph paper because there's a lot of graphing. It's all about graphing, so a lot of graphing. If you wanted to print some graph paper rather than trying to draw some, or you may already have your own graph paper, but if you don't, the very first thing on page 1 of the lesson is a little link to click, and you can print graph paper very simply. So that makes it nice and simple. They got the little roller coaster video to start. Talking about design a roller coaster, which looks like it'd be fun to ride, but I don't see how it would actually work in real life. But it looks like it'd be a cool one. I love roller coasters. But it talks about on page 1 graphing, reviews graphing a line, graphing a parabola. So let's talk about graphing a line, graphing a parabola real quick, just because we need the refresher before we jump into the graphing polynomial functions that we're looking at this time. So with graphing a line, so the review on graphing a line talks about how we just generally can make a table for graphing a line. So let's say that our equation is y equals, we'll use the one they have in their example, 1/2 x plus 5. I'm like, okay, so let's make a table to see our points, x, y points. So we'll do, they use -6, -4, -2, 0, and 2. That's the 5 x's that they choose. So when we substitute -6 in, 1/2 times -6 plus 5, what is the y going to be? 1/2 times -6 is -3, plus 5 is 2. So this equals 2 when x is -6. So that gives us a point for our graph. 1, 2, 3, 4, 5, 6. This is -6, and we go up to 2. So that's the point -6, 2. That is a point that is on this line because the x and the y will make that a true statement. Let's look at -4. 1/2 times -4 plus 5. Well, -4 times 1/2 is -2 plus 5 is 3. So at -4, we're at 3. -4, 3. So that point is on there. -2. Let me write that point. 1/2 times -2 is -1 plus 5 makes it 4. Oh, we're starting to see the pattern here. Now, with linear, we really only needed 2 points, and we just connect them and continue on. But since we have these points, zero, we know zero takes this out, and we're at 5. And 2 times a half is 1, so that's at 6. So this goes to 5, and this goes to 6. Really, with linear, we only needed 2 points, and then we can connect them and make our line. All right, so graphing linear equations pretty simple. We can make a table, plug each of these x values that we choose. We choose our x values and decide what the y is, and we can graph a linear equation rather simply. Okay, so let's look at a parabola. I got a better graph for this. So graphing a parabola, which is a quadratic equation, right? It's an x squared. So let's use, I'll use the back of this one as our scratch paper. Y equals 2x squared minus 8x plus 7. And we're like, wow, graphing that. Well, first we want to find what the vertex is. Remember that? The negative b over 2a. That would be the line of symmetry, which is the x coordinate of the vertex. So b is negative 8. So it's negative 8. And this is all of a negative over 2a, 2 times 2. So negative 8 over negative 4. So 2 is the x coordinate and where our line of symmetry is. So we know our line of symmetry is going to be up and down right there at the 2. Let's find out what our y is. So when x equals 2, the y equals 2 times 2 squared, because the x should be squared, minus 8 times 2 plus 7. 2 squared is 4 times 2 is 8. Negative 8 times 2 is negative 16 plus 7. So we got 8 minus 16, which is negative 8, plus 7. So that equals negative 1. So our vertex is at 2, negative 1. So we can go ahead and draw that point on there. We know that's the turning point. That's the turning point. That's the vertex, which means it's either the minimum or the maximum. So looking at the x squared term, this is positive. So we know that this one goes up. So that means our vertex is a minimum. So this graph is going to go up from that point. All right, so we've learned a lot already. So now we'll choose a couple of points on each side of our vertex to make a table. But we need to know where the middle was. So since the middle is at 2, let's choose 0 and 1. So we'll be on the 2 points to the left of it. And then we'll choose 3 and 4. Okay, so if x equals 0, this will be a 0, this will be a 0, because it's all being multiplied by 0, so it's going to be 7. If this is 1, 2 times 1 squared minus 8 times 1 plus 7. 1 squared is 1, so that's 2 plus 7 is 9 minus 8, so 1, 1. What about when it's 3? 2 times 3 squared minus 8 times 3 plus 7. 3 squared is 9. 2 times 9 is 18. Negative 8 times 3 is negative 24 plus a 7. So 18 plus 7 is 25 minus 24. So that also is a 1. And now let's evaluate it for 4. 2 times 4 squared minus 8 times 4 plus 7. 4 squared is 16. 2 times 16 is 32. We got negative 8 times 4. That's negative 32. Okay, those cancel each other out. 32 minus 32. So we just have plus 7. 7. So if we graph that, we have the point 0, 7. 1, 2, 3, 4, 5, 6. Right there. We have the point 1, 1. We have the point 3, 1. And we have the point 4, 7. So now we know what our parabola looks like. Make it a U shape. And we can graph our parabola just by finding the vertex and picking the points on either side of it. And with a parabola, we're not surprised that they have the same values because it's like a mirror, right? This is the line of symmetry, so it should look the same on both sides. So 1, 1, 7, 7, that's not a surprise. Okay, so that was graphing quadratics and linear, which was the review part on page 1. We're not even to the new part. So now this lesson is talking about graphing higher degree polynomials, graphs that are to the third power, to the fourth power, higher degree. And what we need to do is understand how they're affected by their power, first off. So if something is to the third power, okay, we've got f of x equals x to the third power. We can make a table again, right? So we can figure out a few things about what that graph looks like. And we can just do the standard -2, 1, 0, 1, 2 right around the origin. So -2 to the third power. So -2 times -2 times -2 is a -8. -1 to the third power. -1 times -1 times -1 is -1. 0 times 0 times 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So what we see is we get the same number for 2 and -2, except for different sign. So the ones on this side are negative, ones on this side are positives. So if we're looking at that on a graph, I'm going to graph this in red. So we have 0, 0. We have -1, -1 right there. -2, -8. 1, 2, 3, 4, 5, 6, 7, 8. Then we have 1, 1, and we have 2, 8. 2, 4, 6, 8. 2, 4, 6, 8. There's 8. Okay, so we have those points. And it's not a straight line. Notice it goes over and then starts going up. But that gets us started on that. We found the corresponding y values, and so we can plot them and kind of graph it. Now, what we're seeing is that when we graph this, we have this curve over to here, and it should be a pretty smooth curve. It's not corners. We don't make a corner like they're all straight lines. It's a curved line. When a graph moves over, it's a curve. So that is what the graph of f of x equals x to the third looks like, just off making these points. So then we can understand what happens. We can see what an x to the third looks like, but what happens when we have like x plus 2 to the third? That's a transformation of something for it. We have a plus number in here, right? So when that happens, this is going to shift to the left, 2. If this was a minus, it would go to the right. Remember, this goes just opposite. When it's inside the parentheses, it goes opposite. So that graph, get a different color here. X minus 2 to the third power would just move, every point would move over 2 to the left. And it would look like this. Same graph, just 2 to the left. That's f of x equals x plus 2 to the third. So understanding when we see some of this, we know what x to the third looks like. It's going to go from negative infinity, cross the x-axis, and then go to positive infinity. If we had a x to the third minus 5, that would shift it down. That would shift the whole graph down. So all of these points move down 5. 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5, and right there. So when we graph that, again, it's the same graph. It's just every point is shifted down 5. If this was a plus, it would shift up. All right. So we understand what those things do. If we have a number in front of it, like 3x to the third, all right, 3x to the third, what that does is it makes it go up faster. So instead of this being 1, this would be a 3. Instead of this being 8, it'd be at 24. So it would get skinnier. So instead of the graph looking like, that, it might be really thin. No, I didn't even put any curve in there. There should still be a curve in there. It'd be really thin. It would just, you know, would not have much left and right. It would go up and down a lot faster than this big move over. That would get skinny, that move over, because suddenly it's going up faster. This move up here, this move down here. So you see when this comes down, still goes through 0, 0, but it's coming to these points. So we got to pay attention to all of those things. And we can always make a table and do those kind of things. If this is a negative out front, that's another important thing. What if we have f of x equals negative x to the third power? That's a negative 1. What that does is it totally reverses to where now you're going up on this side and down on this side. So it's coming from the positive. It's going to go over. It's going to go down to the negatives. It changes the direction of the graph entirely when we have that negative 1 out front with that x to the third. So now it's going to go up to infinity, and on the right side, it's going to go to negative infinity. So those are the things that we're looking at in this lesson. And this has lots of examples for you to go through, and it walks you through step by step. Find the x-coordinate of the turning point first. So the x-coordinate of the turning point is just when this equals 0, right? So when x equals 0, it's 0. We knew the turning point was going to be at the origin. The turning point would be at negative 2, because we would take x plus 2 equals 0, subtract 2, x equals negative 2. And see, the turning point came at negative 2 on that one, on the green graph, because this was x plus 2. So whatever's inside the parentheses, set it equal to 0, and that will tell you where the turning point is. That's where it turns. It's not turning at 0 anymore. Important to understand those things. Let's look at a quartic function. Quartic. It's f of x equals x to the fourth. X to the fourth, a quartic function. So again, we'll just do a table of values. X, y. Choose our standard negative 2, negative 1, 0, 1, 2. See what it's doing around the origin. Since this is just an x, if this was an x minus 3 to the fourth, then we would shift everything over 3. So this would be like negative 5, negative 4, 3, if that was x plus 3. So negative 2 to the fourth power. So that's negative 2 times negative 2 times negative 2 times negative 2, which is the fourth power. Negative 2 times negative 2 is a positive 4. And this negative 2 times negative 2, those are both positive 4. Right? So it's 4 times 4. So this is a positive 16. Put that over here while we're building this. Negative 1. Negative 1 times negative 1 is a positive 1. Negative 1 times negative 1, positive 1. Well, it's just going to be a positive 1. 0 to the fourth power, 0. 1 times 1 times 1 times 1. 2 times 2 times 2 times 2. So if we see what's happening here and graph this, we're at negative 2, 16. Negative 2, 2, 4, 6, 8, 10, 2, 4. Oops, I lost it there. Let me mark these. There's 5. 1, 2, 3, 4, 5. There's 10. 1, 2, 3, 4, 5. All right, there's 15. Kind of put some scale on our graph where we can kind of see. So negative 2, 16 is going to be right there. Negative 1, 1, 0, 0, 1, 1, and 2, 16. So this looks a lot like the x squared parabola, but it's going up faster. Goes up faster. Let's go back to our original. See, this one's wider. This is going up faster because it's to the fourth power. So it gets a lot steeper faster. This would both went up 1, and then the next point only went up to here, where this one went way up to here. So it's going up much faster when it's to the fourth power. But that is what a fourth degree. If this was a negative, right? If we had a negative 1 out front, negative x to the fourth. Exact same graph, upside down though, right? 2, 4, 6, 8, 10, 2, 4, 6 would be way down here. F of x to the negative fourth. Anytime you have that negative in front, it's going to reverse the ends. So the important things to learn in the terminology you want to use is end behavior. What is the end behavior? All right. So this one to the left goes towards infinity, and to the right goes to infinity for the red graph. Right? If we're talking about the green one, this would be negative infinity. With our third power graph, to the green one, left goes to negative infinity, but the right side, the right end goes to infinity. So the left end goes to negative infinity, going down forever. The right end goes to positive infinity. So you want to use those end behavior terms, and it'll be talking about end behavior. So as you go through this lesson, pay attention to the terminology they're using and end behavior. We have a couple of videos on page 1 of the lesson. Then it talks about graphing it with technology. So then you can go to Desmos, or if you have a graphing calculator you like to use, you can graph it on your calculator, and it will give you some problems there and talk about the end behaviors. Some of the graphs they will have, if this was more than just x to the fourth, let's say, for example, it's here. I use the purple one since I'm putting on the same graph. F of x equals negative 4x to the fourth minus x to the third plus 13x squared plus 4x minus 8. So there's a lot to digest there. But really, the overall behavior will be based on the largest exponent to the fourth. So that means the ends are both going to go the same direction because it's an even power. Second power, fourth power, sixth power, eighth power, any of those, the ends are going to do the same thing. They're both going to go to infinity or both going to go to negative infinity. And when you graph this one, this is one of those graphs that's going to kind of look like this. Something like that. But it's going to be over by the origin. It's going to be over here, like the origin's right down here. That's going to be your y-axis. I just didn't draw it on top of this. So this is one of those does this stuff right here, because all of this other stuff underneath there affects what happens in between the ends. But the ends still both go down because this is a negative 4. The negative makes the ends go to negative infinity. All kinds of stuff that can happen here based on everything else that goes with the equation. So that's where you got to make a table sometimes and pull those points out there. But this is one that they have you graph with technology. So when you see these things going on, then there's other things you want to talk about. You want to talk about end behaviors of graph, but you also want to talk about maximums and minimums, right? And these are not maximum, right? These are just the minimums that we're going to run across, but there is lower points, right? There are lower points than that. So that's not this is not an absolute minimum or an absolute maximum, because this one actually is an absolute maximum. There's nothing higher than that. That is an absolute maximum. But the other ones are not absolute because there is lower points and higher points for the other ones. This is a relative maximum, right? Just for this area of the graph, if I just look at that area of the graph, that is the maximum. It's just relative to that area. And this is a relative minimum if I look at the rest, if I ignore the rest of the graph. But it's not the absolute minimum. This has no absolute minimum because it goes to negative infinity. Absolute maximum, relative maximum. It's just relative to that area because on both sides of it, there's smaller numbers. So that's a relative maximum. So those are other features. So this is all about the features of polynomials when you graph them. So when you look at the lesson summary talks about the end behaviors, which are important. Does it go up, up? Does it down, down? Does it go down and up, or does it go up and down? Depending on whether you have a third degree or first degree or fourth degree. The other thing we look at in this lesson is the average rate of change. We look at increasing and decreasing and average rate of change, right? So if we look at increasing, decreasing, this graph from negative infinity to here is increasing, right? That is increasing all the way till that point. And then until it gets down to here, this is all decreasing because the y's are going down between this x and this x. From this area to this area, where those x's right there, just those x's right there shows decreases. Then after that, it's increasing all the way up to here. This is all increasing. So these x's from here all the way to here, these x's are increasing because the y is getting bigger for those x's. And then, of course, we see decreasing. So this has increasing, decreasing, increasing, decreasing, just because the y's are going up and down, up and down. So we say the x value from that point on is decreasing. So we talk about increasing, decreasing. We talk about maximum minimums. We talk about end behaviors. But the other thing we can look at is the average rate of change. And so let's talk about the average rate of change. If I want to know the average rate of change from here to here, right, here to here, that is talking about if it was a line, if it was a straight line, it went from that point to that point. What's the slope? So we're going to call this the point. We're going to use this as the y-axis, 1, 2, 3. This is going to point 3, 1, 2, 3, 4, 5, 6, 7. So that's the 0.37. And this is going to be, we're going to call it -1, -1. So this is going to be -1, -1. So what is the slope between -1, -1, and 3, 7? Remember, we subtract the y's, 7 minus -1, and put it over the x's, 3 minus -1. So 7 minus a -1 is 8. 3 minus -1 is 4. So 2. The average rate of change is 2. That means for every x, it goes up 2. 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 Now, what it really does is it goes way down here and goes way back up there. For some of that, it's decreasing. Some of that's increasing really fast. But if I'm just talking about these 2 points, the average between those 2 points is a 2. For every x, it's going up 2. Average rate of change. If we were looking at a graph, let's just draw a freehand graph here. We won't even have an equation with this. We're going to say, all right, if I go up to here, goes up to this point, and then it comes down. All right, so this is obviously an odd, like a 3rd degree or a 5th degree or a 7th degree, because this end is going to negative infinity, that's going to infinity. So this is a positive x to the 3rd or x to the 5th or x to the 7th, just because look at the end behavior, we know what it looks like. If we want the average rate of change, what if I said, what is the average rate of change between x equals -5 and x equals -1? Who can tell me what the average rate of change is between x equals -5 and x equals -1? I'll give you a chance to put that in the chat. I'll even highlight those 2 points. So x equals -5, 1, 2, 3, 4. Oh, that was when the graph is right there. And x equals -1 is when the graph is right there. We see in between there, it increases till it gets there, then it decreases till it gets there. But I'm not asking about increasing, decreasing. I'm asking what's the average rate of change between x equals -5 and x equals -1. Four. Okay, there's a good guess because it went from 4, right? And it went up 4. Is that the average rate of change? So this is 5. Okay. I don't have a right answer yet. I'll tell you that. I like you guys are thinking. You're trying to figure this out. Remember, the average rate of change means the slope. Let me give you that hint. The slope. That's the average rate of change, the slope. So now thinking about that, what's the slope between x equals -5 and x equals -1? even draw it for you if you want me to make the slope we're looking for. We're looking from the slope from those 2 points right there. What's that blue line I just drew? It's hard to see the blue, but maybe I should have used a different color. I'll highlight it in orange. What's the slope of that orange line there? How much does it go up? Remember, it's rise over run, right? So rise over run. Oh, there's a 0. The rise. How much did it rise? The rise was 0. How much did it run? It ran 1, 2, 3, 4. 0 over 4. The average rate of change, there you go, it goes over. The average rate of change is 0 between those 2 points. Between there, it goes up and back down, but it goes up and down the same amount. However much it went up, it came back down because it's in the exact same place. So when we talk about average rate of change, we're just talking about the slope. If we chose this point and let's say this point here, we would just be talking about what is the slope of the line that goes from here to here. That's all we're talking about. Average rate of change. Average rate of change. When you see that, just think, what is the slope? Average rate. Oh, sorry, move that over. Average rate of change is just what is the slope between those 2 points? Just 2 points. And you can do the y2 minus y1 over x2 minus x1 when you get the points. This is the point 2, -2, and this is the point -5, 0. Right? So if we look at the purple one, we can just subtract them. -2 minus 0, that's just -2, right? And this is the point 2 minus -5. 2 minus a -5 is 7. So the slope was -2 sevenths. That's the average rate of change between there and there. So anytime you hear average rate of change, just think slope between those 2 points. You can draw a straight line if you need to. If you want to put it on paper, draw a straight line and just calculate. Ignore all the red. We don't care about all the red when we're asking about the average rate of change between 2 points. You're just looking at the slope between those 2 points. We know actually between there and there, the graph goes way up, then it comes back down and goes lower than that point and then comes back up. But the average, if we had the slope of every one of those points and took the average, it would be a -2 sevenths because that's where it ends up. Okay, so that's really what this lesson's all about. Understanding all the different behaviors, being able to graph this without technology and with technology. It's a skill to do both. You need to be able to graph things without technology and graph with technology. So graphing without technology requires you to understand the turning points or the vertex when it's a parabola, understanding the end behaviors as it's going up and down. Maximum and minimums is important. When is the graph increasing? When's it decreasing? And where are the zeros, right? When we factor it and get the zeros, that tells us where it crosses the x-axis. And we can make a table and get those things a lot of times. So tables are very useful. Just substituting that x into the equation, figuring out what is the y at that x value. So it gives you a point, an xy point to graph. And then understanding transformations. If you know what the graph of x squared looks like, and then you just see x parentheses plus 1 parentheses squared, you just know, take the graph of x squared and shift it over -1, right? Because x plus 1 goes left, x minus 1 goes right. So you got to think about it goes the opposite direction. Or if you see x squared plus 3, that's after the x squared, then you know it just shift the graph up 3. So you can just do the exact same graph as x squared, just raise all your points 3. So understanding the transformations makes it a lot easier too. So understand the parent functions. What's the graph of x squared? What's the graph of x to the third? What's the graph of x to the fourth? What's the graph of just y equals x? The diagonal line, right? Diagonal line. So just understanding those and be able to do transformations can save a lot of time too. So that is lesson 3.07 in a nutshell. Again, there's a lot more detail in there. They walk you through more examples. They give you a better understanding as you're working those out on paper. And as the technology part where you're putting them on Desmos or your calculator or whatever technology you like to use on that, and doing that. And then after that, you just have the practice test for all of Unit 3. So that's it for this week. One assignment, one practice test, and then due by Halloween. So not to throw anything else at you. So remember, tomorrow is the PSAT. It's on campus. It's here at the virtual school, which is on the campus of Bentonville High School. So for those of you who have to take it, seniors, I know you're not taking it. You should have got an email from Mr. Vest. Basically, you just won't have any classes tomorrow, so you'll have some free time to get your work done. I don't know if they have anything else going on for you. I haven't seen the schedule for seniors. All I know is you're not taking the PSAT and you don't have any classes. So check your emails from Mr. Vest on what you might need to be involved with tomorrow. But those of you who are not seniors, PSAT tomorrow. But that's it for class. If you have questions, hang around. Otherwise, I'll see you next time.
Let's get out of here. Word to your multiples. Math, baby.